So we will discuss the NumPy. Uh, the NumPy is how this NumPy is useful and where do we use it. All those things we'll discuss in today's session. So NumPy is a numerical Python. NumPy is numerical Python. Basically, it is very useful for it provides the n-dimensional array object, a ND array for efficient data handling, so that it can be this using n-dimensional data object we can easily work. Uh, uh, so NumPy is the short name for the numerical Python. It's a fundamental library for scientific computing in the Python. It provides a powerful n-dimensional array object, that is ND array, which is essential for handling large data sets efficiently. Unlike standard Python lists, NumPy arrays store elements of the same data type in a contiguous block of memory, enabling highly optimized and vectorized operation. So, the basic thing is the NumPy normally as not like list. List in the Python. Python list can be of different types. Okay? You can store in the same list string or well float as well as a boolean or well a numerical or any type of the data we can store in the Python list. But coming to the NumPy array, the basic thing is all the elements should be of same type. Okay, so all the elements of the same type, like all integer or all floats or all strings or something. So here in NumPy array, all elements must be same type, and because it is a restriction of storing all elements of same type. Normally, the memory allocation will be same, right? And it can store in a contiguous element, like side by side in memory. Because of they are contiguous, NumPy can directly use efficient CPU level instructions like SIMD or a single instruction or a multiple data, which will perform the operations on multiple elements at a time, because all of them are a common same data type, which are in the same one. They are beside one side by side. So because of that property, it can perform. Say it want to do a multiplication with 10 for all elements. It can do that multiplication parallelly. Normally, if you are writing using the C program, what you have to do, you have to use the two for loops. Okay, or for loop or repeat, all those program you have to do, where you will be doing continuous. But because the storage is of same type and side by side, it can do a parallel computation in the NumPy. So that makes it very fast to execute. Okay, it makes the NumPy data type too faster to execute. It can perform the numerical methods very quickly. So here we are talking about the vectorization also. So vectorization means applying the operations in an entire array at once. So that's what I'm talking about. Parallelly executing means we are making it vector without where this entire array we can perform any operation on entire array without using the explicit loops in the Python. So that is the main advantage of this NumPy. So NumPy is much faster than the large scale numerical computation, and its memory efficiency, it uses less memory compared to the Python list. Scalability is there, where essential for data intensive fields like data science, machine learning, and image processing and scientific computing. there is scalability on of this NumPy. So here, while working with the NumPy, uh, simply it starts with starts typically it starts by importing NumPy. Okay, uh, 1 minute. So simply by importing NumPy as NP is the object where what we are doing, this line of code, like we discussed in the pandas, allows you to access all the NumPy functions, all these NumPy functions and objects by prefixing them with the NP. So what we are doing, all the NumPy functions and objects we can use with the NP. So how we are saying, instead of you specifying numpy.array, we can simply specify np.array. Okay, this is a widely adopted convention which is crucial for readability and collaboration with the Python scientific computing. So this is how we import, right? And we work with that. Then we are coming to the important and core of the NumPy, which is high performance and dimensional. That is n-dimensional array object. That is a fundamental data structure for scientific computing in Python. Unlike Python list, uh, an n-day array stores all elements in a contiguous memory, right? So simply we take some example. Like say we are taking in healthcare industry. In healthcare industry, if you take a MRI scan, going for next slide because I'm facing an issue with. So we are talking about the ND array. So first of all, we'll import the alias NP using the import and NumPy as NP, and we can access the functions like NP array, NP zeros, NP reshape, and all. So we are discussing about ND array object, which is the core of the NumPy, which is a very high performance n dimensional array. So this ND array. When you talk about NumPy, we should remember ND array. So it stores element in a contiguous memory, all elements of same type, which enables the vectorized operations. As I said, vectorized operations means parallelly we can do multiple operations on the same data, same array at a time. We need not to use the loops or anything. Like if you are taking an MRI scan as a 3D ND array, okay, height, width, and depth are the main three values, right? We can store here three-dimensional ND array, right? With data of MRI scan can be stored in three-dimensional ND array. And we have the attributes for this ND array with ndim, shape, and data type. Like we discussed earlier, arrays are, when we talk about normal arrays are a short structured list of the numbers like vectors, matrices, images. Okay. If you talk about the vectors are normal, a single dimensional array which you can represent. Matrices are a matrix, and images are like this, and tensors are like this, convolutional nets are like this. So there are different categories of these arrays, right? So when we want to create an array, we can simply create using the, here you can see waypoints is equal to np dot array of, in the parenthesis we can give the list of the array. Okay? So that's we'll check now all these things. We can do the vectorization, like we can do the operations on whole arrays without loop by simply here say voltages is the array. We can multiply that with the 10. Okay, then the total array values will be multiplied with the 10. And say in the healthcare, is high BP. We can, if you want to check all the BP values, all the patient BP values in a list, in a array, and if you want to check who is having greater than 140 BP, then simply you can check with a simple operation. That is advantage of Numpy. If you do that, like arrays uh, can can have any number of dimensions, including zero. Like without any values, we can a scalar value, or can be one dimensional, and arrays can be typed like uni 8, uni 64, float 32, float 64, like that. It can have of different sizes. That also we can specify. Here you can see data type is float 32, like that we are specifying. While creating the A array with np dot array in the parentheses, we are writing that. When we print n dime and n a shape and a data a type, it will print all those digits. Okay. Then we can also create arrays with np dot one function, np dot zeros, np dot arrange, np dot concentrate, and np, and we can also use np as type, zeros like, ones like if we are if we want to print np dot one, it will when we give 3 comma 5, np dot ones of 3 comma 5, it will create 3 rows and 5 columns. And d type with np float 32, we can simply create. So that is a simple command. We'll try to execute that right now in a 10 minutes. Let me cover the top. np.arrange is the one, okay, where it will create from 1334 to 1338. The n dot n minus 1. From the starting value to the n minus 1, it will create. And it can concatenate to array. Okay, so you can see first A is the one and B is the another one. Okay, using np dot concatenate, we can concatenate the two matrices. Okay, and zeros like, ones like that, we can create random numbers also. We can create all those things. We can perform using this arrays, or we using the basic operations. So here basic operations is the first one is most powerful feature is vectorization, which allows you to apply mathematical operations to entire array without any explicit for the list. And the second category is indexing and slicing. Okay, the third is manipulation. Okay, we can do the manipulations. We can create using ones and zeros and all, and we can also broadcast it. First, we'll see whatever examples we have seen, that we'll try to execute. Then we'll cover to the next topic in the this now. Sorry, I came to this way. First thing, we want to create some array, right? So first we want to create some arrays, and using those arrays, we want to work. We want to do some operation. First, we'll create an array on this. So first, how we can create an array? So by simply using the np dot array, okay, in using that function, we can simply create an array using the simple np dot array, and in the parentheses by writing, we can create an. So how we can create some array is equal to np dot array in the parentheses. Then we can write as many lists we want to create, we can create. right? We can write simply here, but we should remember that we should use the same data types, right? We should not do that. We should not use any other data type. So simply the first example is we can use num array function to create in any array. So it has created an array, right? So if you print, it is showing. So we have three properties, right? So what are these three properties? Either shape, data type, okay, and all, which tells about this. Uh, what are the different size as well as the values in this particular and the data structure, right? So the the basically we can create NP like this, and when we are creating this NP, we can use n dimensional and shape and all, right? So what we said, print of data. So it's a 3 into 3 matrix, right? In the same manner, if you want to know the dimension, we can use the dimension. I wrote it, spelling mistake one. DIYM I wrote, I write DIM. Okay. So like that, we can, it's a two-dimensional, right? So that is the reason it is showing. We can have n-dimensional because the main, this ND array main advantage, pandas main advantage is we can have multiple dimensions. Okay, and we can also ask for this uh, data type also. So it's in 64, right? So like that, we can create the basic pandas this numpy object, and we can work on it. We want to create an what we said ones ones or zeros. Okay, then simply we can create zeros or ones of any of zeros ones matrix also for our easy doing any operation. Like if I want to create A is equal to, okay, NP dot one. Okay, so what once, and here we need to give the data type and the size also we need to give, right? So when you are creating any NP ones or NP zeros, you have to tell the rows and columns and DP type. The data type, there are plenty of data types. We have float 32, float 64, and all. So that you can directly specify that. So how do we specify in the parenthesis? Say 3 comma 5 or any value, 4 comma 5 comma d d type is equal to float 32. Okay, NP that we have to specify using the NP dot float 32. Then we will close. So this is how we can create a matrix of one. Okay, okay. Here it created the 4 rows and 5. In the same manner, you can create uh, A is equal to NP dot zeros, where you will give the size 5 comma 5. Okay, comma B type is equal to NP dot flow 64. So it has created, and this is print A. It will show us the 5 into 6 matrix. So like that, we can create any number of any uh, any any dimensional matrix, and also zeros and ones. For example, we have taken the zeros and ones. So we want to create, we want to check for the what vectorization. So that is what is vectorization in list. If you want to perform any operations on all the elements of the list, it has to use the list. But when we are talking about vectorization is the main advantage of this Numpy, where these things will be performed at a time parallelly. So here we're taking sensor voltages with 0.5, 1.2 and 0.8 value. Okay. So you want to convert those voltages to the meter. Then what you have to do, okay, or you want to multiply, okay, multiply all values with the 10. Then what you do, new data is equal to the whole data sensor star 10. So what happens immediately? It works very fastly. At a time, it will parallelly execute the. So if you print the new data, but we can compare by giving the huge data set. Work on the huge data set, right? So you can see the float values which are 0.5 multiplied with 5. So at a time we can perform. You need to use the loops here. Normally, when you go with the matrix, you have to use the 2 for loops. When you want to apply any updation on a matrix, you have to use the 2 for loops. Here you need not to give anything. Say you want to perform this a into some 15. New data is equal to. We'll try to add 15. Whatever it works. Because zeros are there, we cannot do multiplication, right? So all the values are at a time since we need to use the loop here. So that is the advantage of this Numpy. So if you are writing a C program for applying any addition or subtraction on a matrix, normally you use the 2 for loop. Here you can simply do directly. So that is the advantage here. Then say I'm talking about another example. Say BP readings are there. These BP readings we want to check the condition, right? So there you can directly check the condition. What happens? All the falses and all the truths. Okay. So how we can check it? Is underscore high underscore BP. So that is the output we want to get, which is equivalent to so BP underscore reading. BP underscore reading. And we want to check with the values which are greater than 140. Okay. So now you check for this print is underscore high underscore BP. Then it will print here this is one BP which is true, and another BP value which is greater than 140. Like that we can perform, that we call as at a time. If we can perform any operation on these values, that we call as vectorization in Numpy. Okay. Then another category is applying different operations like concatenation, all these things you can check. Or if you want to create what we call random calculating the or developing a random number. So you want to do some create a random number. Okay, then you can use random operation. Okay, np dot random of 10 comma 3. Then if you do like that, then obviously we can generate a random number like random random underscore opt is equal to np dot random. Okay, two random. Then we can give the row values and column values. Always row values is we start with the row values, then we will give the column values. That you have to remember. Say 10 comma 3. So, print random underscore opt2. So it is creating 10 rows of random objects. Okay. So that is the main advantage of this random or one zeros or one. Okay, and vector array, we can apply at a time any vector operation on this. And coming to the next topic is indexing and slicing. Indexing and slicing means here you want to have the only some values in the total array. In the total array, you want only the we want to have only the few values that we call as slicing. Indexing means referring any value in the total object that we call as referring. Say we want here, using the row values and column values, we can represent anything like you can represent row values, any value. If you want to get this, you can use the rows and values. Already we discussed in the data frames and all. Say you want to get the first, say you have one array like robot pose. Robot pose means normally it is represented, robot pose is represented by 6-element array, 3 for the position and 3 for the orientation, right? So robot pose is a 6-element. We normally we use for the position and 3 for the orientation. Okay. Say you want to know only the position, the first 3 values. Then what you'll do? Position is equal to what is the object robot underscore pose, okay, bracket colon 3. What is the position? The robot pose is not defined. So did I wrote any spelling mistake? I hope I haven't written any spelling mistake. Okay, that's correct. Then why it is not working? Column 3, it should work. Yeah, we
Sir,
are.
they're saying uh, uh, you didn't run the above cell robot post cell. They're saying.
Okay, okay, yeah, yeah. Now I have run, right? That's the reason it is executing. Yeah. So, so this robot force first three values you can give using the column, right? So this, if you are saying an example of healthcare, normally if you have a time series of patient ECG signal, we can use a Boolean masking to filter out the abnormal value, right? Say I'm creating I'm creating a signal, okay, using the random ECG signal I'm creating using the random values. So what I'm doing here, I'm creating a patient ECG signal. I'm simulating, okay. So I'm creating 50 values, star 0.5 plus 0.1, okay. If I print, so these are the different signals which are generated. Say if I want to filter the noisy spikes above 0.5, if I want to filter the noisy spike, okay, above 0.5, how I simply use the I'll simply use the clean signal. Okay. So what I'm doing, I'm cleaning the data by simply taking the values which are of 0.5. So here, the clean signal, I don't know. So all what I have done here, so we have a we can here we are applying a Boolean masking to filter out the abnormal rate. So that fall outside of a typical range. Normally, range it should be less than 0.5. So that we are filtering out. That we are filtering out. Okay. So so those that fall out of the typical range, which might cause it by the noise or regulatory heart rate, that what we are doing here, using that, we're updating the data. Okay. So here we're only considering the values or all. So if I give like this, we are only considering the values which are less than 0.5. Okay. Then another important function is array manipulation. These functions, uh, these functions allow you to change the array structure. Like it is they are critical for preparing the data for different algorithms. So we need to at the particular space we need to change the structure of the image or a structure of the array. Okay, in that case we have to use different array manipulation function. We have to use the different manipulation function. Okay, let me the examples I've shown. Let me Divya, are you there? Divya,
Yes,
yeah.
sir.
So here, this is creation. This is shaping. What we are doing here, we are reshaping the array. So here, initially, the array is A is a unidimensional, right? That we are reshaping into the 3, 2. Okay, and again we are reshaping that to 2, 1. So like that, we are changing the shape of any array. That we call as shaping. That we call as shaping of the any array. So this is very important while we are applying the data clean. Okay, the another important method is slicing. As I said, we can get a slice of the data. Array manipulation, which changes the structure of the arrays to fit the algorithm. Okay, so to fit the algorithm, we can apply the change of any data. Okay, see here, say we are talking about the NP step, right? So here we can say we have taken uh, one image with the left image and right image. That example I will say. In this, when we are implementing this, using this Numpy horizontally stacks array, meaning it joins them side by side along the column. So the left image and right image, we can join them by side. Like the basic example is we are taking an array of 1, 2, 3, another B array 4, 5, 6. Then we say a stack of uh, A comma B. Then both will be combined. If it is a unidimensional array. If it is a multi-dimensional array, again we can parallelly 1, 4, 2, 5, 3, 6 like that we can combine in a two-dimensional array. That we call as H. Okay, like that we can do the manipulation. I'll show you that example right immediately uh, while class is going. Then another category is broadcast. Broadcasting is again another feature. Okay, another feature in the this Numpy. It is very powerful that allows the Numpy to perform operation on arrays of different shapes. Okay, it is a key to vectorized operation. When two arrays of compatible shapes, Numpy can expand the smaller array to match with the shape of the larger one. Okay, so what is here happening? The smaller array is matching the shape of the larger one. So for the vectorization, what is vectorization? Applying the any operation at a time parallel to all values. So in a robot control, you might in robot control, we'll see that example also. But what is that? In a broadcasting, we can perform the operations on arrays of different shapes without copying the data. And it is very efficient for the vectorized calculation. Okay, so that is we talked about array manipulation. Okay, we can change the structure of arrays to fit the algorithm. Another one is broadcasting and transposition. We can transpose an array. Okay, if you know the matrices, you know matrix operations, you know what is the use of transposition. Okay, then another important is saving and loading the array. We can use the NP get value, which can hold the multiple arrays, and we can also compress using the save jet underscore compress. Okay, so we'll see all those things. We'll see the linear algebra, how the linear algebraic operations can be performed. Let me come back to the topics which we discussed till now. What is that? Array manipulation and broadcasting. Then the transposition also will discuss. Okay, we'll try to practice that. Then we'll go to the further step. Thing we are talking about the Numpy array manipulations, right? Array manipulations we are talking about. Manipulations means we can change the content or the size without we can change the structure of any any data. Say we have taken a left image with 100 into 100 zeros. I'm taking the left underscore image. So this is one value. Okay. NP. So NP dot zeros means what happens? It takes the simulated data, right? With object of 100. 100 rows and 100 columns. The first value mostly it specifies. Then I'm taking the right image. So we have taken two images. Then if you want to stack the images side by side to create a stereo image, what we'll use? We'll use a. So let me print 100 into 100 means it will. Okay. So it is printing very nicely. Rows are 100 and columns are 100. Okay, it is using the dots to decrease the size. Sorry. Okay. Now I am creating the zero. And we can give the left image, comma, right underscore image. So when we use this, if you try to check the shape, it will have the 100 into 100, right? Normally now it will have the 100 into 200. Okay. So if you see the size differences, you can see side by side, it will be stacked. First zeros, then 1. So we'll have another example like, as I said, say we are taking say we are taking another example like healthcare. Okay, a flat list of patients is a flat data set of patient records are there, which are need to be reshaped into the 2D matrix for the analysis. So we want to do the analysis. Then we want to convert that into the. So that first we'll take a patient's data with NP array. Okay, then we'll try to convert that into the matrix. Okay, so this is the data. So here we want to convert that into the matrix. Simply, what is the function we have to use? We have to use the reshape function. We have to use the patient's data dot reshape into 3 into 3. And when we print this, it will be converted into the matrix. Okay, so this is one example. Okay, so here like that we can reshape here the which is in the uh, single unidirectional or a one dimensional array. We are what we are doing for our easy uh, purposes or requirement need, we are converted that into the matrix. Okay, so like that we can do the manipulation. We can do the manipulations on any object, right? And we can also perform what we call broadcasting. So what are the broadcasting? We can perform the operations on arrays of different shapes without copying the data. What is broadcasting? So say we have an array of waypoints. Okay, here this array. So we have array. So what is how many dimensions it is having? It is having 2 into 2 matrix, right? If I print it, the waypoint, it is a 2 into 2 matrix. So if I want to add a global offset of 5.5 to all waypoints, if I want to add, the offset is 5.5. Okay, offset is 5.5. So you better learn some matrix operations if you are not confused, because matrices are very important in the algorithms which are used in ML, right? Matrix operations. Sometime I will try to explain that also. So here offset I have created with 5.5. Okay. Then what I want to do, the offset array is broadcasted to each row of the waypoint by performing the plus operation. So you can see print new waypoint. So what happened? This five five is added. This 5 is added to the all these uh, elements, to all these elements. So, so if I am saying, so here you can see for this column, this offset is added, right? For 1 and 3, the first offset is added. Like that, you can perform a broadcasting operation using the this NP object. Okay, so offset is 5 is added to the first column because it is in first column, and 6 is added to the second column, right? So like that you can perform the broadcast operations. That what is a broadcast? So we can, it allows us to perform the operations in array of different shapes, and it is a key to the vectorized operation. It is a key to the vectorized operation. And say and don't be confused with this broadcasting, or and another one is what we use edge tag. Say you have to so let me again I'll explain the edge tag. Say I have taken the two values, two arrays. One is A and another one is the B. Right? If I print both, print A, this is 1, 2, 3. It is showing into the column because we have defined as a row list of objects. Then if I print B 4, 5, 6, if I hit tab, okay, what happens? What happens? It will what it will do? It will combine both in parallel, right? So how do I do the hit tag? Print result is equal to HNP dot H tag, okay, comma. Divya, is my screen is visible? Divya, Divya, is my screen is visible? Divya, is my screen is visible?
Yes, sir. It is visible, sir.
I could not see my screen. Something went wrong. Just I'm logging out because I I have a one. Okay, just I'm logging out. Uh, just I'm logging out. Okay, so 1 minute. Yeah. So if I apply, is my screen is visible, Divya?
Yes, sir.
Yeah.
It is visible, sir.
So what happened? Both have on both that was hit stack horizontal stacking was applied, right? And we have another, and the difference between this stack and broadcasting concepts are people mostly often confuse about stacking like stack and with broadcasting in number, but both are they are different concepts. Stack is purpose concatenates the arrays horizontally side by side along the column. Requirement is arrays must have the same number of rows, right? In a stack, arrays must have the same number of rows, okay? And we can apply. So what is a head stack? Concatenating the arrays horizontally, okay? Broadcasting is little different for the same it allows the arithmetic operations on arrays of different shapes by automatically expanding uh, one with the one or both arrays without actually copying the data. Okay, so it follows the broadcasting rule. It compares the shapes from the last dimension backward, and dimension must be equal one or one of them must be equal, must be one. Say here, I have given you one example, that is NP stack. So what happened here? It added one column with the fourth. The one is added to the side by side. It concatenated the error side by side. So one is added with the 4, 2 is added with the 5, and like that. So we are talking about this broadcasting here. In the HC stack, both should be have the same number of rows. Okay, but in broadcasting, it allows arithmetic on arrays of different shapes. Okay, we'll take two. One, we'll take the two arrays of different shapes. Say here we have taken okay, two shapes are there. You can see. If you print so this is one shape, and the other is another. B is one shape, A is of another shape. It is having 3 rows, and it is having one row with 3 values, right? So both are different sizes of array. So here we can apply the broadcasting. In the previous case, what happened here? Both are having the 3 rows. Okay, both are having the 3 rows and single column, right? So here we can apply the like operations we can perform. In the previous case, we both columns and rows of both arrays are same. Then we can use the H stack. Okay, here we can use the instead of H stack we can use the broadcasting. So here you can see result is equal to A plus B. So this with 3 rows with a single object, we are performing the operation. So what happening? What is happening? This 10 is added to the all. This 20 is added to the all, and 30 is added to the all. The first column, first value is added, and it has been created as a first column, and second, okay, and third, like that it is created, and it created it has reshaped into the new matrix with 3 columns as well as the 3 rows, and the new object, the B which we are adding is 10, 23, right? 30, right? So because it has the 3 columns, the 3 rows and 3 columns combined, it has created near about every column value is added with the every row value. Every column value is added with the every row value. Every column value is added with every value. So like that, an A plus B operation is performed. This we call as broadcast. The initial previous one we call it as H stack. Okay, we are applying the H stack, which will be add side by side. Okay, most of the people will be confused. You please don't be confused. Okay, so that's it about the most of the operations in Numpy. And transposition also we can simply do, and we can perform the file operations also, and we can simply perform the statistical operations also. any statistical operation, mean, median, or any function, we can simply apply on the data. Say we have a patient's temperature. We have the patient temperature of say some values we have that patient's temperature. One minute. So we are creating the patient temperature. Some patient data is equal to say 36.5, 37 point. We want to calculate the mean. So how do we calculate? Simply we'll give the use the np dot mean and np dot mean and the object. Okay. So mean underscore patient is equal to np dot mean. Like that, any function, any statistical function we can apply. Simply we'll give this option. Okay, or you want to find the max. Simply we'll use the max underscore is equal to np dot max of patient underscore temp. So like that, any kind of uh, statistical operations, most every statistical operation will be available with the NP object. All those things you can call. So 38 is the maximum, right? You can see 38 is the maximum value, or min, or median, or anything, any statistical operation. Simply you can call that function. If you Google, if you go to the documentation, you can get any most of the functions which are available in the Numpy. So that's it about for today. We will close here the Numpy. I hope we have practiced a little bit the Numpy. This usage of the Numpy will practice in the all our algorithms. So tomorrow we'll discuss with scikit-learn, okay, and sci-fi also will discuss. Then we'll go for the TensorFlow. Then parallelly we'll start the clustering and classification and all. Okay. Thank you very much for listening. Thank you very much. And we have a client, as we said, need to recruit for a client project. So they're asking about any experienced or any trained. Our training is not sufficient actually. We need to get, we need another up to all the 90 days training. But if anyone is already got